Hello, everybody. Wait, isn't that how she says it? Hi, guys. I'm Zach Dunn, and my partner is Thomas Satoli, and today we're going to be talking about the merge sort algorithm. No, we're not talking about like cars merging into other lanes on the highway and causing accidents like this guy right here. So, what is a merge sort? It's an efficient sorting algorithm that uses a divide and conquer strategy to break down a list, i.e., it divides a list into smaller sublists, as you can see right here in this picture. So this becomes these four, and then these two, and then this, until it's one element. So we want to keep dividing until we get to one single element, like this line right here. Once this is done, it merges them into a sorted list, and it uses recursion. The specific case we're talking about right now is top-down merge sort, which uses a recursion mechanism. Like I said before, it starts at the top and proceeds downward with each recursive turn asking the same question, such as, what is required to be done to sort the array? And having the answer as, split the array into two, make a recursive call, and merge the results until one gets to the bottom of the array tree. So that's division. Now merging, which is also the conquering, the first element of both lists is compared. So these two are compared. And sorting in ascending order, the smaller element array becomes a new element of the sorted list. So this will become the new element. This procedure is repeated until the smaller subsets are empty and the newly combined sublist occurs all elements at the bottom of the sublist, which is right here. Now, bottom-up merge sort is basically the same idea, but instead of using recursion, it goes through iteratively. And as I explained, I want you to notice how the size of the array doubles. That's because it's making more space. So the bottom-up merge report uses iterative methodology. It starts with a single element array and combines two elements and also sorting the two at the same time. The combined sorted arrays are again combined and sorted with each other until one single unit sorted array is achieved, which is this right here. So when we go through, it basically compares the elements and then sorts them. So 3 goes here, 6 goes here, 7 goes here, 2 goes here, 8 goes here, 4 goes here, 9 goes here, 1 goes here. And then we take this down here and then we move it up as our new array. And so 3 goes here, 6 goes here, 2 goes here, 7 stays in the same spot. 4 goes here, 1 goes here, 8 goes here, and then 9 stays in the same spot. And then we take this again, and then we bring it up here. And then 2 goes here, 3 goes here, 6 goes here, 7 goes here, 1 goes to the beginning, 4 goes here, 8 goes in the same spot, and 9 stays in the same spot. So basically all this is just doing is just taking this and then making it into this. So it's just sorting it through so it becomes in a sorted order. So it's running times. It's pretty fast. It's same in all cases, worst, best, and average. It is O n log of n. That's because it divides each thing in half, as we saw back in the slide before, and it takes linear time when we merge it together. The space complexity is O of n, which is not too good, but that's because it has to take linear time to merge them, and it needs to allocate space to like do that. But compared to the other algorithms, it's pretty fast, except quicksort in certain cases, which we'll be able to talk later after this.
Merge sort. Is it stable? Yes, this means essentially whatever order you put it into the sort, it'll come out the same after the sort. So the elements anyway that came before another element will stay that way even when sorted. So for example, say you have four elements, A, B, C, D. If you put them in A, B, C, D, it'll come out A, B, C, D even after sorted. It won't come out like B, A, C, D or D, C, A, B. It just always comes out the same way that it went in. Now, what data does it work best for? It works best for linked lists because of the way that the runtime is. However, it also works fairly well for slow access data compared to other sorts like quicksort. So that means like disk storage or even network attached storage. So no matter no matter what data you're trying to access, it has a fairly consistent runtime, even for larger file sizes. That's one of its benefits, that no matter what file size you have, the runtime is always fairly consistently the same, which is better than a quicksort when it comes to like large data sets or arrays. However, the only drawback to merge sort would be that for quicksort, it's just better for smaller data sets as it's faster It just completes the task in a better time than the merge sort can. However, when it gets to the larger sizes, that's where quick sort really starts to slow down, and merge sort it becomes way better in those cases. Merge sort, is it in place? It is not in place. So for any sublist or arrays that you need to store after the sort, you need to have some storage dedicated to the output for merge sort, because it needs somewhere to put the data after it's stored. It won't all stay in the same place. So you need to have just any extra space to put that output in, which can be slow. But if you think about the benefits, no matter what size file you're trying to sort, it'll always get it done consistently well. So the benefits outweigh the drawbacks.
Takeaways. It's one of the more merge sort is one of the faster, more efficient sorting algorithms to use out there. You can look it up. It's proven. It uses a divide and conquer strategy to sort data. Again, it's good for linked lists, slow access data, and large data sets. But at the end, of course, it needs to allocate new memory when sorting through the data. But in the end, it's still pretty good. I recommend using it over quicksort because even though, again, quicksort is good for the smaller ones, like if you were using a smaller data set, then of course go ahead and use quicksort. But like once you get to the bigger ones, you're probably going to want to use merge sort. Since these are our references, if you have any questions or you want to go more in depth, this is where we got all of our information from. So thank you for watching. Hit that sub button. I want to hit 1 billion subs. Thank you and God bless. Love you.